Welcome to the Pharmacy Seeds Network, or more regenerative media, depending which channel you're watching on. This video is going to go pretty deep into surveying and engineering from a perspective of regenerative farming. So the concept I'm trying to introduce in this video and kind of detail some of the basics on is basically taking a systems approach to farming. And what I'm trying to illustrate here as a big picture is that managing farming and land, and especially in regenerative systems where there's all these details and all these timeline and synergistic stacked pieces to track, maintain, and adjust for over a timeline, it's a tremendous amount of data to track. And I feel like a lot of farmers have a really difficult time tracking that data and reacting and responding to that data in a timely manner that affects their crops in a positive way, instead of letting negative effects take hold and then trying to correct them. So I just wanted to kind of give you a preface for this. This is an introduction to where we're going with the rest of this series. Up until now, we've pretty much covered some basics for regenerative ag. We went into photosynthesis, soil building, microbiology, foliar feeds, and many of the basics that provide the foundation for accelerated plant growth without the use of chemicals and chemical fertilizers and pesticides. So now that we've laid that ground track, so to speak, now we're going to move forward and we're going to start looking at things from a systems approach and a global approach and a big picture perspective. And we're going to have things from an overview. So in the first part of this, we're going to go into the engineering, the surveying, and the land management part of it, and the mapping stuff a little bit. And then as the series goes on, we're going to go into how we're going to go into soil samples in the next part. My soil sample test results will be back, and we'll go into that. We'll look at those soil samples. We'll figure out how we amend the geochemistry of the soil. And then as we go into the season, I'll show you how we manage on a more granular scale how we manage nutrition on a plant and species basis, and even down to
to a new 8-acre block of farmland that I've had a decade of learning regenerative agriculture and refining and understanding the systems and working my farms and marketing and all the different pieces that I've done over the past really 35 years of learning. Now it all coalesces into something that's going to be really freaking.
For those who don't understand surveying, there's a couple things we do in surveying. One thing we do is mark up property corners. I'm not even sure that this is a property corner here, but I found baseline hub and flagging here that indicates somewhere nearby is the property corner. So I flagged it for reference to make it easily findable, because we're doing this survey through aerial drone photography, and it's going to be a little harder to spot precise points with this type of technology, I think, compared to what I'm used to, which is total station, or like a GPS, which is ground-based robotics, and this is aerial-based. So this is the other corner post in the front, and we'll go back through and flag up the outside edges. I will not flag the split lot division, because we're not running 30 seconds from my last clip. Maybe you'll get the point. I don't mess around. I'm going to flag this post. I'm going to find the opposing post over there, if there is one, and flag that. And we'll move on up to the corner where it splits out to a flag.
Idea. We're looking back, and we're about to enter where the lot flags out.
5, 4, 3, 2, 1.
Across this brush line and it flags.
Through the brush line.
Trying to give you an on-ground perspective, so when you see the aerial photography, you can match it up. So I think the line actually splits there, but in order to not cross the line and find the post first, we're going to go north a bit. We don't want to invade other people's space. That same concept about approaching people with respect for communication applies to the same for space, land, living space. Any interaction you would have with other people or animals always should be approached with respect and courtesy. So here's our other corner. I'm going to flag this up. and then we'll go on up that woods line. I'll distinguish another survey difference for people. Most people see posts like this and think this is the survey mark. This is an indicator for the mark, whether it's flagged or not. Stakes like this usually don't mean much unless they specify that on the survey map itself or in the deed. Otherwise, what we're always looking for are re-rods like this. They'll be 1/2 inch to 3/4 to 1 inch iron bars, typically re-rod, and sometimes they'll be labeled. They'll almost always be flagged, and you'll notice that this is set at a bit of an angle. That's because we set the stake and then we set the top of that stake within 0.01 feet. That's about 1/4 inch, and we can hold that across a 100,000 foot distance.
Okay, here we are looking at a map in AutoCAD, and this is a job we did out in Ankrum. It's a 1 inch equals 50 foot scale. This was done in 2008 for Mr. Sigalo. I believe he was an art trader or something like that, art dealer. Anyway, the guy had a really nice house estate put in, and actually even did geothermal on this job. So I think this is my first exposure to geothermal close up from an engineering perspective, so that was cool to see. Anyway, we were talking about baseline, and I was explaining baseline to you. So I'm going to provide 2 different examples in this so you can have a good concept of how surveying works. So this job, I chose this job specifically because it's a great example of a job where 2 different pieces of land are tied together that we need topographic data on, but we don't need topographic data in between them. So you'll see here that these jobs are tied together with what's called control. Now there's 2 different ways to do control. We can do control with GPS, and we can do control with total station. Now there's other ways as well, but we'll stick to those for simplicity. So total station is ground-based. It's a robot, well, it can be done without robotics, but the equipment we had was robotic total station. So it was remote controlled wireless survey gun, which was a really awesome tool to have and use, and very efficient in the field. And the other way to do it is with something called GPS. Well, there's a couple different ways. There's something called RTK, which is real-time kinemetrics, and that's where you have a local GPS station collecting data, and you correspond your field data to that, and you crunch that math down to get resolution of high-quality resolution of elevation. And then there's another way to do it where you use something that's a little bit different. It's similar setup, but you're using a station in Albany, and they collect data all the time, and then you download your data, and then you have reference data to go against. And because it's further apart from where you are, that goes back to that rotation thing, it actually gives you a better resolution. All right, so that's just basic information. So normally we use total station, and we use something called baseline in total station, and that's what you see here. This is these red lines here are baseline. So we run these lines, we set up a point in the ground. It's a metal spike, a magnetic spike, a fixed point that we set that stays in the ground. And that point gives us a point we can come back to later and set up our tripod over. And then our tripod sits over top of that perfectly vertical, perfectly plumb, and we set that up to sit perfectly plumb so that our point is always exactly over the point that we're trying to measure. And then we measure the distance from the point on the ground to the bottom of the tripod, and we record that. And then as we go along and measure elevation, distance, and direction with the instrument, we can actually record elevation, distance, and direction. And so that means we can actually record elevation data. So if we record enough elevation data points, eventually what you build is what's called a 3D mesh. And from a 3D mesh, you can build a topographic grid like you see here, these topographic lines here. For example, here this is a proposed building envelope inside, just outside of a preservation area. Now, this isn't built yet, but you can see where proposed topographic lines are here, where we're going to cut out part of the hill here and fill to make a level spot for the foundation for this building. So anyway, so this connects from
this baseline connects, and you notice we move around on different spots here. The reason the baseline goes to different places so you can set up at different locations where you can shoot a straight shot, because we have to have straight, clean shots directly at anything we're adding to the map. So we set our instrument up on one, we set up what's called a backside on the other, and in this case we have a reflector, and basically we fire a beam at that reflector and we measure the distance with that beam. So this robotic gun actually uses two different technologies well, multiple different technologies, but two different light-based technologies combined into one to do measurement. One technology it uses is infrared, and that's so it can track the prism on top of the staff or on the back sight or foresight. Those are the target points that we use to shoot precision. The other one that we use is actually used to take measurements, and that uses laser. And laser actually is very precise because we're using light, and so it's very hard to distort that distance measurement. And that's what we're looking to do. Over an atmospheric air condition, we're trying to take precision measurements. So remember, atmosphere can distort light, lasers, infrared, radio waves, and the like. So we're trying to avoid that distortion as much as we can. Anyway, so you set up on one with the instrument, you backside another, you measure the angle between those, right? So you have a backside here, and you'd have a foresight, say, out here. So you'd have a prism here and a prism here and the instrument here, and you measure this distance and direction. So you measure the distance here. Sorry, I'm trying to coordinate this for you. You measure the distance of this line and the angle between this line and this line. And then you'd measure the distance of this line, all by one setup on the instrument. Then you set the backside up that was here, up here, and the instrument that was here comes up here, and the foresight that was here goes up here, and you set here, and you turn back, and you measure the distance and angle again to here. And through doing that, you basically build out a locked-in multiple measurement picture of angles and distances of where you're going in the map. And then at each point on the map, with this station, with the instrument, as we stop along the way, along this route, we take our shots. So like here, there's not much to take. We had to just traverse through here. It's called traverse. So we traverse through this, where we basically just run a baseline through it to carry our control points out to where our next shots will be. So once we got past that slope there, obviously that's a slope from the topographic, right? We got down here and we had some stuff we had to shoot in. Like there's an oak tree here. There's a high density polyethylene pipe, 15 inches in diameter at a 1% grade, you know, that kind of stuff. So, and then a lot of these pieces are proposed buildings and structures and stuff. This was quite a project we did, and I think I have some other video footage of this around, and maybe over time I'll dig that out and share it. But I just want to give a good explanation of baseline and how it works in surveying so you can have a better perspective. So this is an open leg baseline. Usually we would run a closed loop baseline, and I will dig up and show you an example of that. Because typically a closed loop will give you a much better connection. I'll explain that. Alrighty. This is an interesting one. This is a job we did down in Unionvale. A very big job. This job was about 100 acres. And we did full topographic, and we built driveways and cottages and McMansions, and good Lord, what a huge job. So just looking at this map, you can see how big this piece of property actually is. You can look at the topographic here, you can see, you know, it's dropping in 10-foot increments here. So when we first came here to this property, all we had was corner pins. So we came in and we shot total station across everything and got all the corner pins in. Then we ran some control data. I can't remember if we did GPS for this one or not. I don't think we needed to. No, I think we did need to. I don't know. Anyway, we ran some control data basically first, and then we had the aerial photography company fly over and take aerials, and then we send them the control data
and they take the control data and the aerials, and they generate these topographic, 2-foot accurate topographic maps. They have to be accurate for lots of reasons. For example, this driveway here was run over a lot of crazy terrain. There were spots in this driveway where we're doing 50 foot of cut fill, like 50 foot of fill to fill in a ravine, and 50 foot of cut to fill over a knoll, to cut through a knoll. This was a tremendous project, and I wish I had more video of this project, because it would have been a really cool example of some of the stuff we did. But I just thought I would show you a bigger project and explain why we do what we do on a little grander scale. And you can see here like stone wall and fence line and stuff like that in the survey data here on the map. And you can see spot points on elevation. Yeah, like here you go. Alternate number 1 caretaker's cottage barn, proposed pond. We did in fact build those. You wouldn't believe the terrain that was there when I had to go first cut through that to survey. That was incredibly rough terrain. It's all thorns and prickers and swamp and just rough, really rough. So we came across this stream and put in a culvert and cut a roadway across this. And this spot even here was just like, you know, it would look like a hard spot to start hiking from, let alone cut a roadway into. Let's see, here's baseline here running. That was a primary baseline. I remember setting up on that many, many times, because I'd have to set up here, backsite here, and then I could stake out for roadway and culverts and all that kind of stuff in here. And all along the stream there's wetland flag, and it was just a crazy amount of data in this project and a crazy amount of surveying and engineering work. And we had to go through special easements, and yeah, you can see this document is loaded with a tremendous amount of data. So I just want to show another example of why elevation data is so important and why it being accurate is so important. I mean, you can't have 30 foot of error like you would with GPS and something like this. You don't want a house 30 feet in the air, right? All right, I mentioned that we did this with aerial, and I just happened to find the map that we did the aerial with. So here's our control baseline. This is a great opportunity for you to see everything here. You can see our baseline here with our BL points, and you can see previous surveyors' work where they're calling it station. So different surveyors use a little bit different naming code sometimes, but at the end of the day, what I really wanted to show you here was the loop. And this is an excellent opportunity to show you the loop and the control data all in one. So you'll notice that this runs all the way around in a long, big loop. And that gives us the opportunity, because we know how many angles there are inside of this loop. That tells us we know exactly how many degrees it should all add up to. And because of that, if we run the loop and we measure each of the angles in those loop, and as you saw, we measured those angles multiple times from multiple setups ultimately. And once we've done that, we can calculate what the total loop closure is, and we can calculate what it should be, and then we can calculate what our error is. And that gives us a controlled loop, basically, as a place to, you know, basically through this loop, we have a way to control the angles and lock this in as something that we can count on as a way to take measurements from. And then once we have something we can count on and take measurements from, when we zoom in, we go along a roadway or a stone wall, or we shoot in a pin, we can turn to that from one of these baseline points, like here, the stone wall corner, right? We can set up on this baseline here and shoot the stone wall corner. And now we know, because we've set up on the baseline, that we have solid controlled data. So at the worst case scenario, if we had one baseline that didn't close well, and we would see that in the field data, because we record all of our field data both in a field book and in the data collector. So that way, when we come back from the field, we can actually look and see whether our field data corresponds directly to our actual data. And if we find an error, we can go back and look for that error and figure out where it happened. And then we'll know exactly what was wrong. And ultimately, because we know that there was an error, we won't leave that error in there. We'll go back and reshoot that field data and make sure that there is no error in it and correct for it. And we did have to do that in a couple jobs. So we had to go back, like, spring and fall. Spring especially is bad because spring you have frozen ground and snow and the sun coming out. So you set up a tripod on frozen hard ground and the sun had hit it. And next thing you know, the ground is softening and melting. The tripod goes out of level. So that's the basic explanation of that. And then, so what we would do for aerial survey is we run this same baseline for control, and then we set up stuff like out where we can get visual contact from the air, and we'll put two big strips of white plastic or white fabric down and make an X over the pin. And that way, when they fly over the aerial, they can find the pin that we shot control for and line it up in the photography with the exact precise control data. And then from that, they're able to take and calculate elevation and topographic data from the photography and the control data. I hope that makes sense to you, but basically what we're doing is building a topographic map from aerial photography and solid precision data. So real quick, I just thought I would show you, I talked about rotation and scaling a lot in this video, and I just wanted to show you what I mean by that. If you look here, you can see this is an image tile and that it's rotated from, what would be considered a 90-degree perspective in the drawing. And the reason for that is to make it fit the map, because our maps are all oriented to north, right? So we have to hold north and hold a certain orientation. And so in order to do that, to fit into GIS systems, that means any imagery, aerial imagery that's taken has to be scaled and rotated to fit the map. So it has to scale to fit the map. Like here you can see, where the map is a little bit different from the aerial imagery. And those property lines may, in fact, run along that field there. I don't know on this job. It's been a long time. But I just wanted to show what I meant by rotating and scaling. So we grab an image like this and we go rotate. Here, let me. All right. So we're looking at a different piece of property here now, just to illustrate the concept about property corners and rotation and all that kind of stuff we were talking about. So if you see how we have property corners in the upper left, upper right, lower left, and lower right, those are the longest points on the map. And so if we pick the longest points in the map, when we go to rotate that, we have the closest precision. So that rotation shot that I showed you with the aerial imagery before, we also do that with our AutoCAD drawings. And that's how we align multiple different pieces of property together. And then that way we can create the tax maps that just, that basically delineate actual property lines. And that way when people have a dispute over property, they can figure out whose property is what. And you wouldn't believe the disputes people have over the tiniest things, but it is what it is. So here we're also looking at the blue box. There is the building envelope. And then the bigger dark red lines, the big square like dark red lines, are actually property division. That was an 80-acre block we split into 20 acres. And then now what you're looking at is the drawing from the 2008 garden that I had. So I did all this in AutoCAD and I staked it all out with the survey equipment, thanks to my previous employer. It was nice enough to let me take that equipment home on the weekend and use it. So I used it for my gardens from 2007 on up through 2009 when I was working for him. So that was cool. In this drawing, you can see upper top left, you can see there's like a stream, and there's some green lines that go around the stream. Those are spots where the stream is occluded by brush. Left-hand side, lower hand side is where the irrigation pump is and the irrigation access. You can actually see the suction line illustrated on the drawing there. And there's various details all over and topographic information. And then of course you can see, various electric fence posts, different varieties of plants, the works, all there in various layers. So what I'm really just trying to do here is illustrate that you can take and design something in AutoCAD. You can collect real-time geographic information, design a plan in AutoCAD, and then go paint that plan onto the landscape. We're looking at it from like an angle perspective. I wanted to kind of paint a picture that kind of helps set you up to understand the deeper picture of what we're doing here. So the engineering thing ties into this a lot, because one of the projects, or well, several of the projects we worked on when I worked for the engineer were mining projects. Most of them were soil mining projects. So we would basically work with zoning boards and state certification boards for mining soil and gravel and clay and, you know, materials for construction projects. And we had to be able to calculate volumes of piles and all kinds of stuff for them. And I did actually record a whole video of one we did down in Unionville, and I actually recorded the robotic equipment working and everything. Unfortunately, that video was lost in a hard drive crash, so I can't share it with you. So the spot that you're looking at is right here. This rock ridge here sticks out, and this is a driveway coming up to the main house from the main drive. And they had to cut through here, through this ridge, and the excavators are going to take forever with rock hammers to do that. So we chose to use the explosives to do it. You basically just drill holes to the depth of what they want to cut, or a little deeper, and then they pour it full of ammonium nitrate. This is particularly 1.1D explosives. You can look into that further if you like. And they blow the ridge, and the big rubber mats you see the excavator moving are blasting mats. Those go over top of the rock after they lay charges. Before they blow their charges, basically protects people and equipment from flying material. A lot of energy coming out.
Care if I come up by you?
Got a hard hat on?
No.
I got one for you right here.
Yeah? Ready when you are.
That's what we want.
Thanks, man.
You'll be able to dig that, no problem.
I would say.
Maybe
Quite a hole there.
Opportunity to share some of that tech with you in the future. Meantime, so looking at this from an engineer's perspective, you might see this a little bit differently than somebody who just looks at this from a regular, normal person's perspective. From an engineer's perspective, as you zoom in on this property, you can see all the topographic terrain here a little bit better, and you can see that there's kind of a slope where everything kind of drains into. And you can see that I'm designing our cropping areas that'll be annual into that, so that our water slope, all our water catchment coming from all around, will end up supplying our crops and filling that soil sponge, so to speak. Now, not too far away here is a pond. Allegedly, the bottom of our grow area sits at around 270 feet, and this pond sits at about 261. So theoretically, we could dig about a 12-foot deep hole here, or drive a sand point and pull water from that water reservoir. I'm quite sure when you look at the other terrain around here and swamps and the way that this terrain and slopes run, that there's plenty of water in that aquifer right beneath us if we need it. So that's one part of the perspective. Now, another part of that is, if you look at this from a material pile standpoint, there's quite a volume of soil material here in this, like, say, knoll here. If you were to cut this down and mine it out for its geologic components, right, whether it's rock or soil or clay or sand or gravel or whatever the actual soil profile is in there. But that's one perspective on it. Another perspective on it is if you were to mine it using biology.
And so that's why we're going to call the farm the biomine, because we're using biology to mine geology. And we're going to go a lot deeper into that later in this series. We'll listen to a few clips from a man named John Slack, and we'll go very deep into geology and soil profiles, and how long-term geology forms soil profiles, and how biology can actually transform geology much faster than was previously known, and on and on and on. But what you'll find ultimately is that the geology, the deeper constituents of the geology of the region, produce a geochemical profile, and that geochemical profile is what is the constituent for all the nutrients that will be there, present, and available from a geochemistry standpoint in the soil. And once you understand that, then you understand how to, look at a landscape on a much larger scale and understand what basic nutrients will be there. And so we'll talk a lot more about that in a lot more depth in the future. But I just wanted to kind of transform your way of thinking, introduce you to the idea of this being a material pile. And then when we look at it from a biology mining standpoint, we can place biology on our material pile or our soil or our land, and we can mine it with that biology for its nutrients and constituents. Without depleting it, we can actually build it up rather than depleting it. And so that's the whole purpose of regenerative agriculture, is to build soils and build land and build health and build communities and build quality. And all it takes is a little bit of understanding and knowledge and using tools correctly, and then applying those tools and skills correctly. And honestly, it's really pretty simple. It's a lot of complexity, but beyond that complexity is such simplicity.
Hi, my name is Steve Bossert. I have a commercial drone license, which is known as a FAA Part 107. This permits me to fly my drone for commercial benefit. Today is actually very interesting. It's March 16th. Today is the first day that the FAA requires every drone to be broadcasting what's known as a remote drone ID. And so I'll explain exactly what we're going to be using equipment-wise today, and then we're going to get off and fly our mission. So we have really four devices right here on the full landing pad that I've created. First, we have the drone controller, which I connect my one of my smartphones to, and this is what we're going to control the drone with. This will give us location, imagery, full control, everything. Next, we have an iPad. This is going to be used to monitor the RID signal, which is broadcast from a device on top of the drone. And then finally, we have the drone, and I said 4 devices because this typically counts as 4. So this little black square right here, this is the RID module. So what's interesting with this is it broadcasts GPS location. So there's a GPS in here. It broadcasts the GPS latitude and longitude, direction where the drone is facing, and it also feeds out telemetry like speed and altitude and things like that. What is unique about these is that this broadcasts on standard Bluetooth and standard Wi-Fi. So anyone can download an app called Drone Scanner on iOS or Android app stores. And the reason why the FAA decided to go with this approach is that anyone with a modern smartphone already has the capability to decode a drone signal. If somebody is flying a drone and is not broadcasting an RID signal, they're in violation of quite a number of laws. So this is very important, and again, March 16th, 2024 is the official date. So today is actually really fun. This is my first commercial flight with an RID unit, so very cool. And then this is a DJI S2 Mini. It's quite a small drone. I have high visibility orange propellers on here, and this is what we're going to be flying with. And also as a drone pilot, we'll see how good the camera is. On the arm here, I'm supposed to show my drone license ID, both there and also on the side. So we are all ready to be in compliance. I've also already filed a flight plan with LAANC, and so we're ready to get rolling here.
Okay, so what you're looking at right now is an app that you can use to track. You can just download this for your phone and track drones in your area. It's a new FAA guideline. You must be trackable. That way, if someone's using a drone in your area and spying on you or monitoring you without your consent, you can detect that they're there. So, and then we're looking at approximate property corners from the drone, a couple of snapshots I took from the aerial photography and Photoshop just to illustrate approximate property lines and corners so you can have an understanding of what we're looking at from the drone perspective. We'll go much deeper into the drone photography later in the series here. We're just very lightly touching on the pieces of this. This is all part of a cohesive systemic approach. And it's a very powerful array of tools working in a synergistic stack, just as Mr. Kimfos talks about for farming. We're applying that with engineering, geoengineering.
My way east to where the other property line is thick. I'm not sure exactly where I am here and across, so I'm going to get a screenshot here for you. You walk through a piece of land. Do you have any idea how much data there is to take in if you're observant and know what's going on?
Soils. The simplest way of describing it is fungi break down rocks, and rocks become more fragile, and they crumble, and they have cavities that hold water. And so the myceliation of habitats retains water in the habitat. With retaining water, you benefit plants. So myceliated habitats tend to be more water retentive, less erosion, and support biological communities that thrive within the environment. So fungi predetermine downstream many of the biological communities that live upon the mycelial mats that grow.
These mushrooms, look at the moss, look at the soil, look at the animal manure, look at the disturbance, more moss, lichen, more lichen, lots of lichen. So we have rocks being converted by fungi. There's a lot going on here, and we can amplify it to our benefit. So when assessing a piece of land, one should always consider what resources already exist to your benefit. Just in this spot looking around me, I have giant cedar posts for fences, gates, and infrastructure for plants. I have a cut into the soil here that could be excavated and made into a thermal mass or a microclimate protected zone. Further out, you can make a pond, you can make a step terrace system. There's a million things you could do. Just backed off that eastern property line because it's so thick in there. I don't want to cross the property line trying to establish where it is. And we have a perfect corner point. We have a far south multiple corner points flagged, and along the side we have that corner point at the base or close to it. More importantly, we have a stone wall here. I have a feeling this is going to show up on our deed. Our stone wall and probably trees and corner points along this will be our property line. I'll pull up the aerial photography and show you the property line on the aerial, and then you'll see exactly why I say that without ever looking at a deed.
So real quick, we'll have a look here at Google Earth at the farm. I've imported the property boundary on this, and so we're walking along in here currently in the video, and that's that ridge I was showing you. Here we can zoom in on this very briefly. And you can see I've started to figure out layout for the farm and stuff. I have not completed any of the planning work yet. I'm actually waiting on a little bit better resolution on aerial survey drone data. We shot some survey drone data. You'll see that probably later in this video or maybe the next segment in the series.
All right, we're back in the car. We're going to drive through. Along the property line, I'll flag corner points as I find or see appropriate. If they're obvious, I'll skip them for today. Like I said, we're doing aerial photography. We'll have a much better picture on things tomorrow night when I have survey data downloaded. Aerial, high-quality imagery.
This audio overlay for Spotify so that we don't have audio gaps.
Walking quick here. I don't know, it might be a tree that's corner pointing. It appears to be pretty straight in here. let's keep on up and we'll end up picking up corners from a survey and aerial perspective both. We have this huge maple tree. We'll get to the other benefits of that later. But this tree will block canopy pretty easily, and it'll make it hard for aerial photography.
The camera on first. There's keys of ground going north, but I wanted to see this terrain change here with the grass and soil and everything changes a little bit up top here. It's another example of how much things can vary just across one piece of land dramatically. And here we are with the top corner. What's up, Mikey?
And we're going to go and find the top corner pins and a few other corner pins and just get the property limits pretty well defined. I know where most of these are up here. Getting out of the car, looking around. We're up at the very top corner of the property. And I guess what I'll do is step up on the car and show you a view to the east and around so you get a better perspective. Where we're northwest at the corner here. It's like right in here. And you can see the slope going down to that dip. And then that open strip where we did our soil samples runs down this center section and comes over more to the west side as it flows toward the bottom. And to the east there's hills. And then farther to the east is the Berkshire Hills. And then in the White Mountains and all those. And then beyond that is the Bionutrient Food Association. And beyond that is Boston. Without representation. Here's our other corner survey pin. So we'll flag that up a little bit more. Doesn't need much. And we got a nice deer trail here. So we have animals coming in and out of here. And there is, in fact, water up here like I thought there might be. That's pretty exciting. I can't wait to get a look at that under aerial survey and see what elevation differences are there. We may not be draining toward us like I hope, but I think a concrete monument here that obviously was knocked over at some point or never set. Probably never poured the foundation and set it. And we got a 3/4 inch rebar here. This is our property corner on the northwest side of this piece of land. I'll flag this up good. Again, we have overhead canopy making it difficult to see. So what I'm going to do is flag this a little bit and then I'll run a couple of X's of flagging coming off. So that again, when we shoot from an aerial perspective, those X's will give us a precise point on this point. That precision is important. You saw me do it down in the far corner and you see me doing it here up on this corner. Why am I doing this? I talked about the aerial survey and the importance of that, but there's a bigger reason for this, and it has a lot more to do with elevation than it does actual grid coordinates. So let me explain something to you. In my previous job, well, several jobs ago, I worked for a surveyor engineer. So he's a certified land surveyor and civil engineer. So we could design everything from a septic system to a nuclear plant and sign off on those plans. I was his field and tech guy, basically, as well as an AutoCAD guy. So I had to learn how to do AutoCAD and field work and survey work and engineering work. So we collected field data. We also staked out field data. And part of the field data that we collected for engineering had to be precise elevation data. And the reason for that is things like regulations here in New York State require that a well be at least 100 feet from a septic system, provided that it is uphill in elevation from the septic system. And if it is level with or downhill from that septic system, then it is required to be 200 feet away from that septic system. So now I see you probably get a picture of why elevation ties in so importantly to things. Okay, so we're just going to take a quick look at another drawing. I was trying to find one that had a well and a septic on it, but I couldn't find one of those. But we do have one here that has a septic on it. And this is a great example of shooting topographic. You can actually see the points data in this drawing still sitting on top of all the other data. So you can see like where we ran a baseline in here and set up a hub. We set up the robotic instrument there. And then I ran around with that staff with the prism on top. You can see we shot in stone wall and we shot elevation and direction and distance data all over the place. So then we pull that back into AutoCAD and we build a 3D topographic mesh from that.
And then from that mesh, we build these topographic lines that you see here. So it's a lot of confusing looking data, but what it ends up with is a very clear picture of what you're trying to see and understand. And the primary reason for that is there's a house going here, or there's an existing house. I don't remember the project at all. But we're looking to put a septic system and an expansion septic system in. So the septic would go in, and the expansion would be an option to add on if you add bedrooms to a house and need to upsize the total volume capacity of the septic system. So just to help you understand from an engineer's perspective why we're doing some of the things we're doing, I talk about it a lot, and I want to relate it in a clear and concise way that you can understand. I hope I'm being effective at communicating it. All right.
So it's trying to prevent contamination, in this case, from the septic system into the well. We don't want E. coli bacteria from our septic system or some other bacteria or pathogen as we see it going into our fresh water supply. So concepts like that are a huge, huge driver behind why we are so precise on elevation. And you may think on a farming project that elevation is not that important, but I'll show you why it is, and I'll show you how that applies to regenerative ag and permaculture, and why on this global scale that we're going to start to work on, it's even more important, because water flows from high to low, and if we manage a farm correctly, we capture that water up very high, and we retain it, and we don't let it off the farm until we're absolutely done using it. And then when it comes off our farm, it comes off our farm clean and pure and ready for someone else to use, not contaminated, not with sewage, not with cattle runoff, not with garbage in our water. We put out clean water on the bottom. Our job as part of our farmers is to be a biofilter for all the rainwater that we collect on our watershed, and collect it, purify it, use it to the most efficiency, and then pass it on clean to others. Again, authenticity, integrity, principles and practices, regenerative relationships. These are important.
Some of the pictures you're seeing in this first intro part are actually from 2013, 2014, 2015, but the irrigation shot you saw was from the farm there, and the tobacco and the tomato, and the rest of the pictures you'll see in this sequence are all from that 2007, 2008, 2009, 2010 farming operation at Hardeman Orchards. You're looking at the drawing now, the design drawing for layout for species, varieties, etc. And now what you're looking at is aerial overview, and you're circling the property prior to design and implementation. So this is all shot in Civil 3D AutoCAD with total station equipment and GPS equipment, a combination of the two. And then that was all imported into AutoCAD to develop a 3D mesh model that we could then develop topographic data from. From that topographic data, I was able to develop a water drop projection, which you can kind of see in that profile drawing there. And now what you're looking at is the transition from profile from the model to real time on the actual terrain. You can see I've staked this plot out and mowed around where the stake was, and now you're watching it get tilled at high speed because it's all in time lapse. And now each of these angles that this is shot from is set on a baseline point. So they're shot from the exact same point with the camera set up exactly over the same point for every shot. So from implementation, design to implementation, all of the shots are exactly from the same point, the same angle. So real quick here, we're just going to look in AutoCAD at the original data, field data. I'll show you where I shot data over on the other spot before the guy that I got to rent the property from moved me over to this spot. I really just wanted to show that our baseline comes out here on the top of that hill, and then there's one down where that camera angle is facing down across the block, and the one that we start at was down in here. There's a baseline in here. I don't know exactly where it is, but it's somewhere right in here. I don't know what point number it is, but that's one of the camera angles. And then there's another one over here that's also a baseline that's a camera angle. I basically wanted to just show that this point data is in fact here, and that each of those points was shot just at different times in the season. This was implemented in 2008, spring 2008, and it was staked out using AutoCAD Civil 3D, and at the time it was a Geodometer 600 total station system, fully robotic, fully automated total station land survey equipment. And I had access to that because I was working for the civil engineer and land surveyor, and he let me take that home on the weekend and use it for my garden, which was really awesome of him. So yeah, that was a really nice tool to have, because I'll tell you what, you can set some really straight rows when you got survey equipment at your disposal. Now, I'll tell you, if you really develop your skills, you can actually do that yourself without survey equipment. You get yourself a good 100 or 200 foot long tape and a good 25 or 35 foot tape and some pins, and you do some measurements correctly just to keep parallel, you can lay out anything you want pretty clean. But it's really nice to be able to stake out exact models very clean. And I'm sure you saw in the previous AutoCAD stuff how much detail and precision you can put into a map. And then we can stake any point on that map. Anything on that map can be staked exactly to precision on the land, as though you were painting the map on the landscape. And so that's what I'm trying to demonstrate here, and I hope I've done a good job of capturing it. This is some really old video work of mine. I was very much more amateur than I am today at videography and editing and capturing. But I hope what's coming through to you is that it's really easy to take a piece of property that's completely raw and doesn't look farmable at all. And if you understand all the metrics involved, all the parameters, all the regenerative agriculture, geology, landscape design, zoning, I mean, it's such a mash of complex layers of stuff that you literally need a map like this to manage that much data, in my opinion. I don't think you can visually manage and understand that much data without a way to really represent it well. And that's something we can do in tools like this, because we can turn on and off layers, and we can look at each piece of data independently, and then we can collate that data in a way that's really visually representable to the person. And so you've seen from 3 different angles this plot that I designed. Again, that was 20,000 square feet, 200 foot long by 100 foot wide. And this is that Geodometer 600 total station equipment, fully robotic, wireless survey setup. And that's the data collector and control pad for it. And that's the robot itself with a laser and infrared tracker. And that's my kitty cat Cloney looking out the window back when I lived at that farm. And there's fresh cut land, and you can see I'm staking out rows, and you can see garlic and onions and stuff there planted. That's German white garlic. You can see frost, where I used frost protection with irrigation to stop frost. Let's see, this is basil, I think. Feta leaf basil or something like that. Many plantings in these blocks. They're in like 20-foot block sets. And it's my friend Steve helping me plant stuff and tend to the garden. I don't think you see it in this video, but there was a massive irrigation system. It's a 2-inch pump that I built with an 18 horsepower Briggs & Stratton twin cylinder engine. Again, fully automated, pressure cutouts for burst pipes, all kinds of crap. I went to the max.
So this is both our main and secondary irrigation pumps. They feed off to the valve system. Which controls distribution of water to any selection or combination of micro sprinklers, drip irrigation, and big overheads.
That's my son Jeremy with garlic, helping me harvest garlic in, I think that was 2009. That's a truckload of garlic going out. And that's some varied basil, sweet varied basil or something like that. And those are peppers, Emerald Giant on the left, and some type of purple pepper, I forget, from Baker Creek on the right. And there's a cucumber there. And is another cucumber, two different types. One's like a pickling and one's like 78 and 55 or whatever average. There's a Lola Rosa lettuce, a bunch of different tomatoes and garlic and peppers. This is all stuff that was produced on that plot. Sweet corn, tomatoes, all different types of tomatoes, white tomatoes, really blurry picture of some of the garlic. These are white tomato, those are pretty good. Big white beefsteak slicer. I forget what type those were, but another red tomato. They obviously didn't make the grade. Those were a crimson cushion beefsteak. Those are pretty nice. Or maybe a rainbow. Can't remember. And then, you can see I'm weighing those all out to go to various markets, trying to keep it rolling. And that's a huge watermelon. Carolina Cross 183, I think. I grew some monsters years back. I'll share pictures in the future on those as well. But anyway, so that's basically it. That's an emerald giant pepper, sweet pepper.
All the way to the western side. Again, there's a stone wall here that'll make this delineation real easy for our P-line. P-line is short for property line if you're surveying. Also called PL for short on survey tags when you're logging data to a field book or to a data log file. Again, pretty straightforward stone wall. We have a property marker out here. It looks like our property line actually falls, well, I don't know, it might intersect at the stone wall, and then this is just the south line. I'm not sure. We'll have to look at the deed. I'll have to go to the Columbia County Clerk's office and pick up the deed because I don't see a filed map in the Parcel Explorer. I'll show you a little Parcel Explorer footage here too along the way, just so you can get an idea of how this all integrates into GIS systems for survey, taxes, etc. Anyway, this is our corner, and what we got here, oh yeah, see, that's what we're after. That's our point. So we're going to flag this up fresh again, and again, we're going to observe as we look up that our canopy is really dense, and we'd have to cut this whole tree out of here to do that, and we don't even know if that tree is inside or outside our property line right now, so we're not going to do that. Instead, we're going to take advantage of our technology and overcome with tech, as always. So once we get corner points on this lot, like that far one I have over in the east and far south, and that corner point flag point, that gives us 3 solid survey points. And then as we take aerial photography and we rotate it to match north and other mapping systems, we can rotate it perfectly and we can scale it perfectly to imagery to make it fit in and work with our system. And then we have exact, precise data, aerial imagery overlaid, and elevation datum all in one base file. From that base file, we can develop layers and design and stake out. We can figure out how much cut fill we need, how high things need to be, how big they go, how far from property lines we are, and on down the list, including drives, septic locations, you name it. And what do you see? The new tech that's coming. We got a new app coming. It's going to be just sick. And I've been going on about survey stuff, and I probably bored the crap out of you, so we're going to go back to farming stuff for a minute here. Over here on the land here, we got this nice knoll. And I've been eyeing this as a potential greenhouse or orchard spot somewhere up here, and maybe even like an office or meeting overlook spot, sort of something or other. But I haven't looked at it yet, and I'm going to see what it is. So let's look. Oh wow, it's a rocky high point. Well, this is quite the spot. We might be able to put, maybe with some work, we could put a root cellar in the rock and have a really solid thing. I don't know. Lots of potential in a hard geologic knoll like this. And then, of course, lots of locked up nutrition in this knoll already existing. And then we see the fungi on here. Look at these guys. Look at that. I mean, if you don't believe that fungi eat rock, that fungi is rooted into that rock. This is what they do, and not in this long geologic time like we used to think. Geologic time is a lot faster than we think. They can do these processes very quickly with the right biology. Now, I'm going to show you this here. There's one really awesome resource to find here. Didn't even notice these were here, but that's good news. birch trees. What a powerful medicinal tool, building tool, wood tool, and also chaga, the mushroom chaga for immunity boosting and health, only grows on birch trees. We'll have to inoculate some. Maybe I can catch him. Little bunny just ran off. There's wildlife all through here. This is just really thick, dense, natural, beautiful land. I think I'm not going to chase this post either. I think Joe and I came over to this, but I can't remember how far down it is. And I got about 10 billion other things to do today. So I think we're flagged up enough to do a primary aerial survey, get our survey data. I should be able to pull rotation, scaling, and all that stuff with what we got. And actually, this whole chunk up here seems like it might have a lot more soil than I thought it did. I thought it was all just rock ridge, but I'm feeling a lot of soft clay under me, and that means this is potentially growing area as well. So we probably have at least 5 productive, capable acres here on this piece of land, just from pure cut it and plant annual perspectives. If you look at it from a permaculture perspective, like I do, and you use all those little niches, instead of being liabilities, you turn those into assets. Then we have even more potential here. And I get to be the foliar feed for this farm. I get to be the accelerate and foliar feed. Make this farm bloom out. And just remember, folks, by their fruits, you will know. Step back and show how I dealt with this tree that's so heavy canopied. I brought it way out on this one side. I hope that'll get us around the drone blockage. If not, we'll find a way around it. I adapt pretty well. Of samples as much as possible. Now, in addition to that, you want to set a certain depth at a farm. And I gotta say, it's actually mine. Now it's finally time. So you label it with information on there. Scoop of soil I take out. We got worms all over here. Dude, this piece of land's a win without how to work with this. But we'll get to test and get it officially scientific dialed. As John Kemp says, we don't guess, we test.